All right, let's put on our detective hats. Today, we're investigating a fundamental rule of math, one that seems simple on the surface, but trust me, it's holding a surprising secret. Let's open the case file.
So let's start with our very first piece of evidence. Take a close look at these two expressions. You see the same numbers, the same operation. The only thing that's different is where we've put the parentheses. So what do you think? Are they going to be equal? Let's find out. And the results are in. Whoa. The expression on the left, that equals 2, but the one on the right equals 6. They are not the same at all. This is the big mystery we're here to solve. How can just moving a couple of parentheses lead to a totally different answer? This is the crucial clue, right here. In the world of mathematics, order and grouping, well, they're everything. You can't just move parentheses around whenever you feel like it. This isn't just some random thing. It's all governed by a very specific mathematical law.
And that brings us to the law that's governing our whole case, the associative property. This is the rule that tells us when we can regroup numbers and, more importantly, when we absolutely cannot. Okay, so here's the formal definition, and it can look a little intense, I know. But all this is saying is that for an operation, that little circle symbol, to be associative, the grouping can't change the final result. You could do B and C first, or A and B first, and you have to get the same answer. As we just saw with our first clue, subtraction definitely does not follow this law. So this brings us to our lineup of suspects, the 4 basic operations. Now, it turns out 2 of them are law-abiding citizens, and 2 of them are total rule-breaking rebels. Our job is to figure out which is which. So here's our case board, laying out all the charges. Word on the street is that addition and multiplication are associative, while subtraction and division are not. But, you know, a good detective never just trusts hearsay. We need to see the proof for ourselves.
All right, let's start by interrogating the good guys, the operations that actually follow the associative law. First up for questioning, we have addition. Let's see if the evidence really proves that it's as associative as they say it is. Okay, let's test it out with these 3 fractions. On the left side, we'll add 3 halves and 5 halves first. That gives us 8 halves. Add that to 1 half, and our final answer is 9 halves. Got it. Now for the right side, we'll group the first 2 numbers. 1 half plus 3 halves is 4 halves. Add 5 halves to that, and we get the exact same result, 9 halves. The answers match perfectly. The evidence is just undeniable. Addition follows the law. Case closed on this one.
All right, multiplication. It's your turn in the hot seat. You've got a reputation for being a rule follower. Let's see if it holds up. Using those same numbers, let's run a test on multiplication. On the left, multiplying the second and third numbers gets us 15/4. Then 1 half times that result is 15/8. Okay, now on the right side, let's group the first 2. 1 half times 3 halves is 3/4. And 3/4 times 5 halves also gives us 15/8. It's another perfect match. So the evidence is crystal clear. Multiplication is also a law-abiding operation. The verdict? Associative. That's 2 suspects cleared.
Okay, now for the really fun part. Let's head over to the other side of the interrogation room and meet the rebels, the ones who love to break the rules of mathematics.
We already have a confession from subtraction from our opening mystery, don't we? But hey, every good detective makes sure to get all the evidence on record. Let's really examine the evidence here. On the left, the operation in the parentheses gives us -2 halves. Okay, so 1 half minus -2 halves gives us a +3 halves. But on the right, 1 half minus 3 halves is -2 halves. Subtract another 5 halves from that, and we're left with -7 halves. The results? They're not even close. Well, the results speak for themselves. Subtraction is a confirmed rule breaker. Verdict, not associative. Guilty as charged. Last but not least, let's bring in division. Does it follow the law, or is it out there causing mathematical chaos? Okay, let's look at this last piece of evidence. Remember, to divide by a fraction, you just multiply by its inverse. So if we do the math on the left side, our final result is 2/15. But on the right side, grouping the numbers differently gives us 5/6. Just like with subtraction, changing the grouping completely blows up the outcome. And there it is, our final verdict. Division is absolutely guilty of breaking the associative law. Case closed on all 4 of our suspects.
So, we've closed the case. But, you know, this brings up an even bigger question. why does this mathematical law even matter in the first place? Let's go from theory to practice.
I mean, this is the key question, isn't it? Why does it matter if an operation is associative or not? I promise it's not just something you need to know for a math test.
Because properties like associativity are basically cheat codes for simplifying complex problems. I mean, look at this messy expression. Because we have other properties like commutativity, which lets us change the order, and distributivity, which lets us factor out common terms, we can totally rearrange this thing. By grouping the terms that both have 3/5, we can then factor it out. And just like that, a really complicated calculation becomes a simple one. The final answer is just 2. These rules are the key to finding those clever shortcuts in math. This quote from our source material really nails it, doesn't it? Because multiplication is associative, we have the freedom to group the factors in whatever way is easiest for us, and that gives us a really powerful tool for solving problems.
And that leaves us with one last thought. Math has these very strict rules of order and grouping, but just think about your own life, following a recipe, assembling furniture, even your morning routine. What happens when you mess with the order? The associative property isn't just about numbers, it's a fundamental idea about how structure and order create predictable, reliable outcomes everywhere. Thanks for joining me on this investigation.